Greetings, friends. My name is John Gabriel, and this is the New Calculus channel. So, the last 5 videos were all about the 5 requirements, and we discussed every one of them in great detail. And what I'd like to do is give you a summary or a brief overview of all the 5 requirements all at once so that you can see how each requirement is required for the next. And of course, no requirement can be stated without stating the previous requirement and a few definitions even before the first requirement. So you'll recall that the very first definition we started off with was point, and we talked about how it is primitively defined. First, in terms of motion, direction, which are also primitive, and then we finally got to path and line, which needn't have been a straight line, and then finally we got to the idea of straight line as the shortest distance. Okay, so this here, remember again, is not a line, it's just a visualization. The line is the shortest distance between these two points. Okay, so these circles here show you the requirements. Or the first requirement says that we can have a shortest distance. Then the second requirement says we can extend this shortest distance. Well, since we can place 2 points anywhere we like, all we need to do to prove that this line can be extended is to show that there is a location between these 2 points on the shortest distance. And there is, because if you get halfway, you could put a flag up there and say, right, this is a shorter distance, but it's still part of the bigger, shortest distance. So in effect, you've got your extended line, right? And of course, you can't get a circle without both the straight line and the extended line, because remember now, you don't have any concepts such as rotation or degrees or anything yet. So you have to state the circle with only these 2 requirements. So you can say, well, it's that symmetrical, it's that path, we won't say symmetrical yet, it's that path from which all the distances to the center are the same straight line, and that if any of the shortest distances are extended, as you see here, let's say this distance here is extended, then it will again meet the path. You see, if you don't put that clarification in there, then you may not actually have a circular path, okay? And it may not be at all symmetrical, like I showed you in the video on the circle, where if you take any complete path on the surface of a sphere, it would qualify as a circle if you left out the extended line part, okay? So what is the greatest or the most important part about the circle requirement? The very fact that it is a symmetrical path, okay? That from any part of the path to a given point, which is called the center, I should have put center up here too, but it doesn't matter. The distance is always the same, okay? And so we move from the first 3 requirements to the 4th requirement. But before we actually state right angles and what they are, we start, giving some names and some more definitions. So we'll say, this straight line here is a radius. If it's extended, it's a diameter. If I find the shortest distance between these 2 points, it's a chord or a secant. And then we say, right, an angle can be defined. Well, first of all, before angle, we define an arc. So we'll say an arc is any portion of the circular distance. In other words, the circumference or the periphery of a circle. Any part of it is an arc. Then we can define angle as a comparison or a primitive ratio of magnitudes, whereas we compare a certain arc with the radius, right? So, and we leave it at that. That's all that an angle is, right? And then by symmetry, we can figure out. We can see, we don't have to figure out, we can see immediately by symmetry that if we start at one point of the diameter and we traverse this path, that it will be the same path as if we traversed on this side. So this path here is symmetrical to that path. And similarly, if we drew a diameter here, which by the way we can do because to get to right angles, we show that if this is a diameter and we move from this point to this point and from this point to this point, then this radius here will be part of a diameter that's a perpendicular. So we have the circumference divided into equal parts, okay? And those equal parts are called right angles. And we've said nothing about number because we haven't been able to get to the part yet where we can define what number is. It's far too early. And then the next step we can do is, so I showed you, oh, here's a little blue line here so that you can remember this is an angle and the radius, and this, the length of this arc to this, the length of this arc compared to the radius gives us angle. Right, now to get the parallel lines that we see here, we simply say, well, consider a diameter and a chord, or a secant that you see up top here. And if on both sides, starting from both sides, the arcs are the same, then this chord is parallel to the diameter, okay? So we have parallel lines. And finally, if you go to the video before the last one, I show you how we can determine that the sum of the angles in a triangle is in fact two right angles, all right, or a semicircular arc if you don't want to use the number 2. So I'll show you in the theorem how to form. The theorem says that the sum of the angles in a triangle is a semicircular arc, is a ratio of a semicircular arc to the radius. So all these things are derived systematically with no contradictions and no need to believe in anything. Okay, there are no axioms in sound geometry. Finally, the last requirement is the one I call the constant sum requirement. So if you have any two lines like this black line and green line which cross each other, okay, now remember, if they were parallel, then these angles here would all be right angles because we'd have a perpendicular here and they'd all be right angles and we wouldn't care, right? But so the first requirement says that if you have two lines crossing like the black and the green and a transversal, then on the side of the triangle, because a triangle also is a figure on a circle and a circle can be drawn through the vertices of any triangle. So if this is a triangle, then the sum of the red angles, these red angles, is constant, and therefore so is the sum of the green angles. And moreover, the sum of these red angles is always less than 2, is always less than the ratio of a semicircle to a radius, right? So, which is in effect saying that it's less than 2 right angles. So this is the summary of the 5 requirements which have been incorrectly called axioms or postulates of Euclid's elements. I ask you to become a subscriber, click like, share my channel, and download my free ebook, which has been updated, by the way. I'll place a link in the details section, and I'll also place a link to this graphic if any of you want to use it in your teaching or tutoring or whatever. Now, what you see in front of you forms the foundations of mathematics, because everything that comes in mathematics is derived from this. The concept of algebra, the concept of number, arithmetic, everything, and it all goes back to the circle, which requires the straight line and the extended line, right? So you can do exact calculations with the circle. You can multiply any line segment by any line segment and divide any line segment by any line segment and see the resulting line segment exactly. You cannot do that in algebra. Okay, now I'll show you how to do all these things in my free ebook. So I recommend that you download it, and there is much, much, much more that you don't know. I promise you that if you study my free ebook, you will know more mathematics than all your professors combined. Okay, all your teachers, all your professors combined, because I do know more than they know, and they do not have my understanding, because if they did, they probably would have discovered the new calculus, but they didn't. Okay, neither did Newton, neither did Leibniz or Euler or any of the other fools who came before me. So I encourage you to study these things and to learn mathematics the right way. And I can guarantee you that there are so many things that you will discover when you learn concepts the right way, because I can tell you that I haven't shared everything with the public, and I don't plan to. So there's lots out there. In fact, the most incredible mathematics hasn't actually been discovered. That is something that you can find out if you study what I'm telling you. Okay. So that's pretty much it now. I'm gonna leave it at that. But just remember that everything, pi, square root 2, all the geometric objects, everything that you study comes in mathematics, right up to mathematical statistics, including the Gauss normal distribution, integration, differentiation. Everything goes back to these 5 requirements. There is nothing, but absolutely nothing in mathematics that doesn't come from the 5 requirements, because these are the true foundations of mathematics. Not set theory, the rot of set theory, the garbage you learn in a real analysis course. There is no such thing as a real number, because there is no such thing as any rational number. It's garbage. Okay, the only true numbers are the rational numbers. Well, I'm out of breath and I'm tired, and I think I've gone a little bit longer than I wanted to. This is the New Calculus channel, and my name is John Gabriel. Till next time, goodbye.